In this lecture session under management of quality, now I am going to discuss other important quality principles in product development. In specific terms, I am going to discuss process improvement cycle, variability reduction and loss function, and principle of zero defects in product design. These three principles are followed in any quality organization. Okay, so let us first discuss the process improvement cycle. Now, this particular cycle originally was called the Shewhart cycle because Walter A. Shewhart is considered to be one of the quality gurus. He introduced this particular concept, product process improvement cycle, and subsequently Deming has also used this cycle in several cases. So that's why this cycle is also referred to as Deming cycle. When the Japanese started using the concepts of quality control and improvement on the advice and recommendation of W. Edwards Deming in 1950s, so they started looking at their process, okay, through this improvement cycle. That means look at your process and whether you can identify the elements in the improvement cycle or not. That means the process should be, plotted, or the process should be thought of as an improvement cycle, and you must be able to identify the elements in this improvement cycle. So, if you look at this improvement cycle, which is referred to as the Shewhart cycle or the Deming cycle, there are four main stages. What are those? First one is the plan. The second one is do. When as per the plan, you have to do something. Then you just check. That means you verify whether your performance is all right or not as per the quality norms. And if you find that there is a difference between what you do and what you expect, obviously you have to take some corrective measures. So you have plan, you have do, then you go for verification or the checking, and the last one is acting. And so this is sometimes also referred to as PDCA cycle. Okay, so this is an improvement cycle, and sometimes this is also referred to as the quality improvement cycle. Now, what do you do at each of these four stages? Like at the plan stage, a framework is developed which describes the relationship between quality of performance as determined by the customers and the process performance. This is very, very important. If you recollect, there are three phases: quality of design, quality of conformance, and the quality of performance. So, the quality of performance is the ultimate test of quality, and this is determined essentially by the customers. Now, obviously, this quality you get from the process or from the conformance systems or the manufacturing system. So, the manufacturing system is conceived as a collection of interrelated processes. So, the process performance is ultimately determining the quality of performance. The difference between them should be minimized, and for this the effect of controllable process variables on process performance should be known and measured. That means always related to a particular process there are the control parameters, and what you need to do, that means against a particular say the quality of performance, okay, you need to have process performance through through an exercise called the process settings. That means you need to identify what are the controllable process variables, and given the quality of performance or a set of performance the measures you have identified, to what extent these controllable process parameters are affecting in a positive way the process or process performance levels as well as the quality of performance for the product. For example, for a given product, the customers are not satisfied with the present level of rejections. Maybe the rejection is 10% or 15% like this. So, the customer is obviously not satisfied with the performance. So, what the process engineer does? The process engineer finds that the main reason of rejection is non-conformance of a given quality characteristics, say diameter of the product with the given specifications, and the process performance needs to be improved. Is it okay? So, the exact reason must be known, the exact cause must be known, and here in this case the process engineer can identify the exact, say, the quality characteristics where there could be some deviation in its values. A study is planned to determine the appropriate process parameter settings so that the variability in the process is significantly reduced. This is very, very important, and the rejection proportion is also expected to be substantially very low. Like, say, suppose it is 10% today, so you set a target of, say, 5% at the next stage, and when you can achieve 5% rejection, then further reduction you also plan for, and maybe the next target could be from 5% to 1%. Is it okay? So, and all what you need to do, that means to reduce the rejection percentage or rejection proportion, what you have to do, that means constantly you have to improve the process settings of a given process. Okay. So, this is basically at the first stage you do, that is at the plan stage. At the do stage, the theory regarding the course of action developed in the plan stage is put to action. Okay, so that means you have created the knowledge base. That means different scenarios you have explored, and then for each scenario, that means scenario number 1, say 10% rejection. So, what is the process settings? Scenario 2, like say 5% rejection. What could be the process settings of a given process? So, this way you generate the scenarios, and then what you do? Now you opt for a strategy or you start doing it. That means now you actually you have started processing the component. Okay, so experiments are conducted on the process to determine the required parameter settings, ensuring minimum or no variability in the measurements. That is very, very important. And feedback is obtained from the concerned customers and from the process. That means the experiment is conducted on a particular sample of the components or the sample of products. Okay, and then you just check to what extent you are able to meet the standards. Okay, and accordingly the process settings are determined. At this stage, the company may test the proposed plan on a small scale. That's I've been telling you. Small scale means for a sample. Is it okay? So, for a sample of items, you produce a sample of components, and then you check at what extent you are able to meet the standards as proposed in the plan stage. At the next check stage, the results are analyzed. Okay, it is to be verified if the difference between the customer needs and the process performance is reduced by the proposed action. This point we have been emphasizing. That means the customer needs are satisfied by the quality of performance. Is it okay? So, if the quality of performance is very high, we might assume that the customer needs are almost fulfilled. Whereas, if the quality of performance is extremely poor, you may assume that the customer needs are hardly fulfilled. So, and this product which you offer to the customer, actually the quality of this product is very much dependent on the process performance. So, there is a strong relationship between, say, the customer needs and the process performance. Okay. So, the potential drawbacks relating to other quality characteristics that are important to the customer are also to be looked into at this stage. That means it is a kind of explorative study. That means you start with one quality characteristics, that is the main quality characteristics. Now when you control that one, but along with the main quality characteristics there could be other quality characteristics, and now when you are successful in meeting the requirements of the customers with respect to the main quality characteristics, then you look into the meeting the requirements of the customers with respect to other the so-called secondary or tertiary quality characteristics also. The performance of the process at the recommended parameter setting should be explained in terms of the mean and variance of the output quality characteristics for a representative sample size. Now this is very, very important. So many units you are producing, so many products you are producing. Now obviously there will be unit to unit variation. So to get an idea about this unit to unit variation, so against a particular quality characteristics, okay, the many values will be generating obviously in a continuous production system, and with respect to a quality characteristics you need to calculate the mean and the variance of the quality characteristics. Okay, so this is very important. That means both are very, very important. That means when you look at the mean, that means whether the mean is your target value or not, that is to be checked, and the variance means whether the level of variance, that means the level of, or say or the variability in the process or variability in the product performance is acceptable to you or not. And it is, this variability is inevitable. So obviously present level of variability you must know, and if it is not acceptable to you, you use Wayne's means and the methods to reduce this variability significantly. The performance must be indicative of positive improvement in the product design. Okay. At the act stage, a decision is made regarding implementation. If the results of the analysis conducted in the check stage are positive, the proposed plan is adopted. That is very, very important. Customer and process feedback will again be obtained after full-scale implementation. Such information will provide a true measures of the plan success. If the results of the check stage show no significant improvement, alternative plan should be proposed and developed, and the cycle continues. Okay, so customer needs are not constant. These are the points to be looked into. They change with time, composition, societal outlook and other factors. So the proposed plan is continuously verified. And if the current needs are significantly different from the anticipated, the improvement cycle starts again from the plan stage. Okay. So the point to be noted is that continuous improvement in the process performance vis-a-vis fulfillment of the current customer needs is the main objective of working as per the Shewhart or Deming cycle of process improvement. So Deming's now this is the next important the principle I am going to highlight, that is the variability reduction and the concept of loss function. And we are aware of the Deming's philosophy, and it calls for abandoning the idea that everything is fine if specifications are met. Is it okay? The idea behind this traditional and conservative attitude is that it is assumed that there is no loss associated with producing items that are off target but within specifications. Okay, so there is a specifications range, upper specification limit, lower specification limit, and the nominal value. So whether the value which you get, the actual the value you get, it may be very near to USL, very near to LSL, or very near to the nominal value or the nominal value, but still all the values are treated equally, and this is the traditional approach. So the reducing process variability is an objective that ensures minimization of loss that is due to deviation from the target value. So in pursuing the concept of quality improvement as proposed by Deming, Genichi Taguchi formalized certain loss functions in 1960. I have already discussed what is his definition of quality. that is, the quality is the loss imparted to the society after the product is shipped. So this is his definition. So if the quality is more, the loss is less. If the loss is more, the quality is less. He based his approach on the belief that economic loss accrues with any deviation from the target value. That means achieving the target value is your main goal. And if you achieve the target value, you will win high praise from the customer and yields no loss. So that is the basic assumption. And the small deviations yield small losses. But if the large deviations do occur, obviously you expect the large losses. So losses increase in nonlinear relationship, say quadratic, with larger deviations from the target. And that's why whenever we talk about the loss functions, so we refer to a particular term called quadratic loss function. So the new loss function implies that companies must strive for continual variability reduction. This we have been emphasizing all the time, that any exercise on quality is essentially an exercise for variability reduction. Okay, and only then will losses be reduced. That means our focus should be variability reduction. So if the variability is less, the loss is less, and if the loss is less, quality is more. Any deviation from the customer target will not yield the fullest possible customer satisfaction. Losses may arise. There are many instances of losses or many examples of losses, like say lost, if you have a loss, then you bring in different kinds of problems like lost opportunities, warranty costs, customer complaint costs, and other tangible and intangible costs. So loss should be minimum. Now, even there is a loss associated with the customers not praising the product, even though they are not unhappy with it. So this is the ultimate test, in fact. So you have to be very careful about, that what is his actual, the customer's opinion regarding the performance of your product or regarding the quality of your product. It is important to get people satisfied with the performance of the product or the service we have been emphasizing all through, because these affects public perception of the product and hence of the company. Because even these days, if the quality is consistently good, ultimately you will find that it will have a bearing on the public perceptions about the products. Is it okay? And it may lead to the branding of your product, and that is your ultimate goal. So only through implementing a very, very powerful quality engineering systems in your organizations and subsequently quality management systems, you can brand your product, or ultimately the branding of your product is possible. Taguchi loss function of a product is quadratic in nature. I have already mentioned that. That means the loss to the customer is directly proportional to the square of the deviation of the actual value of the quality characteristics under consideration from its target value. Now this is to be looked into. That means the loss to the customer is directly proportional to the square of the deviation of the actual value from its target value as determined by the design team. Is it okay? So this is basically you must be able to compute in a given situation for a particular product. That means the expected value of the loss by assuming quadratic loss function you will be able to calculate. Okay, and for that data collection is a must. So you collect data, and then with the given data, later on we'll have exercise on this when we discuss in detail the Taguchi method. You will find that against the values which you get for the product, okay, with respect to its quality characteristics, what you need to do, you need to determine the loss. And while you determine the loss, you assume that the loss function is a quadratic loss function as per Taguchi method. So Taguchi suggests that the loss should be measured in monetary terms. This is an important point to be noted, okay, so that everyone is capable of understanding the implications of the loss. This is very, very important in fact, and because the loss can be interpreted in 100 ways from different perspectives, but whatever may be your perspective, it must be converted into monetary the monetary terms, so that everyone get the real meaning of the loss in the same language. A number of factors, both objective and subjective, are responsible for occurrence of this loss. So this is the traditional loss functions, and this particular figure depicts the difference between the traditional loss function and Taguchi loss function. So here what you have basically, for the given quality characteristics, you have the upper specification limit and you have the lower specification limit. That means it is a two-sided specification, the limits case, okay. And this is the customer target value. Usually, unless otherwise specified, it is the midpoint between the upper specification limit or the lower specification limit. Is it okay? Now, this target value you have to achieve. Now, in the traditional approach, any value you get anywhere between in this range, that means the range specified by the upper specification limit and the lower specification limit, they will consider not to have any kinds of loss. But as soon as you get a value less than lower specification limit, then the loss jumps to this level LZO, or just it crosses, the value crosses the upper specification limit. You know that this is there is a step function, and you say the loss is very high. That means this is an unacceptable zone, this is also an unacceptable zone. So, but the Taguchi loss function, it says that my target is the nominal value, or it is referred to as the target. If I get a value which is different from the target, obviously I am incurring a loss. So this way the loss function is depicted. This is one, and that's why it is the loss function as per the Taguchi, that is L1. This is the entire loss function and is a quadratic loss functions, okay. And what you find that this is your performance. Is it okay? That means suppose you have produced some 10,000 units and you get a distribution of 10,000 units. That means unit to unit there is a variation, and this variation is due to some random causes, not assignable causes, okay. So you will have this distribution. What you will find that maybe if this is the performance and you believe in the achieving the target, okay, maybe 70% of the components or the 70% of the units you are getting, and within plus minus 5% or plus minus 10% from the target, okay. So this is obviously it is indicative of improvement performance. So this is your traditional loss function. This is not acceptable. It is theoretically not correct. Whereas you believe in the Taguchi loss function, you can explain this loss function scientifically. So many companies they are adopting this Taguchi loss function, and accordingly they are trying to design the product. Is it okay? So that means it is a real challenge. That means the no deviations from the target is allowed. So this is and then only you will find that your performance is such that that you hit at the target all the time. Is it okay? So the variability is at the minimum level, and if the variability is at the minimum level consistently, then obviously your production systems, your process has high level of say conformance, or your the quality of conformance is at very high level. Now the next the third one, third principle I am going to discuss, that is the principle of zero defects in product design. Nowadays, the principle of zero defects is known worldwide. Now, what is this zero defect? Let us recall that many a time we say that how can you have a zero the defects. Obviously, it is a production system and it is affected by several uncontrollable noise factors. So, how can you have zero defects? Even if say 0.1% defective, but you have to have 0.1% defective. Now, many years back in the early 60s, the US Department of Defense, they have developed a program with respect to their pursuing missile project, and they started calling it zero defects program. For all types of products that organization design, the ZD philosophy should be established across all functions and work units involved in the product development. So, it's a total approach. Whenever one organization talks about the zero defects, that means a total systems approach is a must. The basic of any ZD program is to assure an error-free best performance from a designed and developed product. Okay. Both quality of design and quality of conformance must guarantee the error-free performance of the product. Okay. So, that means we are focusing on quality of design and quality of conformance. Okay. Now, originally introduced and implemented for the pursuing missile project in the USA in the early 60s of the 20th century. Is it okay? And exactly in the December 1961, typical ZD program calls for removal of errors of all types in the working of a product. Now, the question is, what are the possible causes of error? There are three possible causes of errors. First one is the inferior or bad quality of material, parts or the components. Second reason is the inferior or bad quality of equipment and facilities used in manufacturing. And the third one is the human error occurring during manufacturing or while using the product. Now, the errors due to 1 and 2, this point is to be noted that the errors due to 1 and 2, that means due to materials or due to the equipment, can be eliminated by using the quality materials, parts and components from the right and reliable source of supply. I have already mentioned the principles of supplier selection. So, if you follow those principles of supplier selection, so obviously it is possible to get right quality materials, parts and components from the right and reliable sources of supply, and by incorporating the best practices in selection and maintenance of equipment and facilities. That means it is possible that if you wish to have the best possible the equipment in place, you can do that. But in the ZD programs, the main focus is elimination of human error, and elimination of human error is not an easy task. It's a most challenging assignments, and this elimination of human error is primarily emphasized in any zero defects program. The kinds of human errors that may occur may be of two types. One is intentional and the second one is unintentional. Unintentional human errors, there will be unintentional human errors, but these errors are a function of individual aptitude and can be minimized or eliminated by instituting proper training and skills enhancement program for the workers. So, this always any company, they take up such programs for the workers, so that unintentional, they have the right kinds of skills and aptitude, and so that unintentional human errors come to almost the zero level. But the main problem is how to eliminate the intentional human error. So, this is a serious problem which is primarily due to the human attitude. It can only be removed by changing the attitude or the mindset of the persons considered, and by incorporating appropriate design parameters in the design of the product, and also by consideration of ergonomics of human machine interface. So, this is very, very important. This point is to be noted. That means in today's context, while you design a system, and the systems will have the human elements, systems will have the machine elements, and while you produce something, there is always an interface, there is always an interaction, and this is referred to as many a time the human machine interface. So the key the issue is that you will create a quality systems, but in today's context, while you develop a quality systems, you should focus on how to create a quality human machine interface. Is it okay? There are cases where the equipment is very good, the person is otherwise very good, but we really do not know when the person is put on the machine whether the output which you get, whether it will be of good quality or not. So the interface design is the key, and interface design is a challenging task. So achieving ZD remains a challenge to management in most cases, and only through removal of root causes of a problem ZD can be obtained. And in order to sustain the benefits of ZD over the time, companies must strive for excellent use of all kinds of resources at their command, both physical as well as human. So here, any ZD programs, the emphasis on how to eliminate intentional human error. And if you go through the original ZD programs as it is documented, you will find in detail that what sort of action steps you have to adopt or you have to take so that the intentional human error doesn't exist. So this is the important principles, almost a few important principles we have discussed, and these have high relevance with respect to the product development, with respect to the product quality.